Let's start related rate problem. Well, I think this is the most difficult problem in this whole class, but this is also really obvious problem, okay? Let me tell you the setup of the related rate problem. First of all, you will have like two variables. For example, x and y. Both of them are the parametric function, okay, which is x is a function of t and y is also a function of t. Let me give you a diagram, then you will understand much easier. Okay, here we go. So you have xt and y of t. Okay, and then like in the problem, for example, the rate of change of one side will be given. Okay, which means dx dt is given. Okay, then in the problem, we're gonna ask you to find dy over dt. This will be the question, okay? So this is basic setting for the related rate problem. Then how can you find or how can you solve this problem? We need one important thing, okay? Let's say it is the bridge equation between x and y, okay? So you will have the equation between x and y. But it must include x and y, okay? But keep that in mind. Since your x and y's are parametric equations, then you will take the derivative with respect to t. Then you can find, okay? This is basic setting. Then from this basic setting, I will guide you how we can solve, how we can take care the related rate problem, okay? So let me show you the problem. Let's start from this problem, okay? So as you can find in the problem, you have two variables, x and y. But both of them, they assume they are both positive, okay? And also, like we're gonna talk about at the instant when x equal to 4, okay? And then, like look at that, this line. The rate of change of x with respect to t is minus 2. What does that mean? We can write, okay, let me write here, okay? You have first variable x of t. The second variable is y of t. You will find this one in the problem later. And then, like the second sentence. They said the rate of change of x with respect to t is negative 2, right? So which means dx over dt is equal to negative 2, okay? And then look at that. The related by the equation x cubed plus 4x squared equal to 84. So I can say that is the bridge equation, okay? Just connect these two by this bridge, right? Equation is x cubed plus 4y squared equal to 84, okay? And the last one, oh, I missed one thing, right? At the instant when x equal 4, that's also important information, okay? Your x equal to 4 at this instant, okay? Then what is question? They ask you to find corresponding change in y, which means dy over dt is a question, okay? So this kind of word problem, you have to figure out what the question is, okay? So here we go. The question is finding dy over dt, okay? All these are given information, and this pink one is the bridge equation between x and y, okay? Whenever you set up this one, the next step is we're gonna take the derivative. But keep that in mind, it must be with respect to t, because x and y's are the function of t, okay? So let's take the derivative. Okay, let me do it here, okay? For fun. With respect to t, okay? They keep that in mind. This is implicit differentiation. So x cubed prime is not simply 3x squared, but you have to multiply dx over dt, okay? Don't forget this, okay? Then what about 4y squared prime? It is definitely simply 8y, but don't forget, you have to multiply dy dt. I'm talking about the trainer, okay? And what about right hand side? Is 84 prime is equal to 0. Okay, that's it, okay? Now, once you take the derivative with respect to t, then now we're gonna double check all the information is given, okay? Look at that. X, yes, it is given 4, right? And dx over dt, it is given negative 2, right? And there we go. dy dt is question, but y is not given. Whenever you have missing information, then you have to go back to the bridge equation and given information, okay? You understand what I'm saying? So we're gonna plug in 4 into x, then you can find y, okay? Here we go. Let me do on the side, okay? To figure out the y value, okay? So, since the given information x equals 4, then the bridge equation, 4 cubed plus 4y squared is equal to 84. Then 4 cubed is 64 plus 4y squared equal to 84. And subtract 64 on both sides, then you're going to have 4y squared equal to 20. And divide by 4 on both sides, then y squared equal to 5. And take the square root on both sides. But keep that in mind. Whenever you take the square root, you must have plus and minus sign, right? So I can say your y is equal to plus and minus and square root of 5, okay? But in the problem, we assume your x and y's are both positive. So we're going to take the positive only, okay? So now that's it, okay? Look at that. Let me come back. X is given, which is 4. Dx dt is given, which is -2. And we found y, which is square root of 5, at this instant, okay? And then dy dt is the question, right? And that's it, okay? So now we're going to plug in everything. Then you will get the answer, okay? Here we go. 3 times 4 squared. And dx dt is -2. And plus 8 times the positive y value square root of 5 times the target variable dy dt. That's it, okay? So like 4 squared is 16 and 3 times 16 is 48, sorry, okay? And times -2 is -96, right? So like since we don't have enough space, let me move up here. Okay, sorry about that, okay? So it's -96 and then plus 8 square root of 5 times dy dt is equal to 0, okay? Plus 89 on both sides. 8 dy dt is equal to 96. And divide by 8 square root of 5 on both sides. Then dy dt is equal to 96 over 8 square root of 5. Then we can just simply cancel out these guys, okay? So your answer is 12 over the square root of 5. Or if you want me to do the rationalized denominator, then you can do like this way. 12 over 5 and square root of 5, okay? I just multiplied square root of 5 over square root of 5, okay?